Hello students, welcome to the video lecture 7 of the chapter Magnetism and Matter. Today's topic to be discussed are classification of magnetic materials, diamagnetism and paramagnetism. Let us begin with classification of magnetic materials. Substances are categorized according to their behavior in the presence of external magnetic field. So according to that, we categorize them into three groups. They are diamagnetic substances, paramagnetic substances and ferromagnetic substances. So let us start our discussion with diamagnetic substances. The substances which exhibit diamagnetism are called diamagnetic substances, or we can also define it as diamagnetic substances are those which have tendency to move from stronger to weaker region of external magnetic field. This means they are repelled by the strong magnets. Example for diamagnetic substances are bismuth, copper and lead, etc. Let us also note that the magnetic moment of diamagnetic atom is zero. They do not possess any magnetic moment at atomic scale. Let us now take the properties of diamagnetic substances. The first property is diamagnetic substances are weakly repelled by the strong magnets. As shown in the screen here, when we bring a strong magnet very close to the diamagnetic substance, it gets repelled away feebly. Second property is when the diamagnetic substance is placed in external magnetic field, the magnetic field lines prefer to pass through the surrounding rather than through the substance, as shown beside. Third property is in the presence of external magnetic field, diamagnetic materials get weakly magnetized in the direction opposite to that of applied magnetic field. Let us take the fourth property. The value of susceptibility is small and negative. So that means chi lies between -1 and 0. Thus the value of chi is negative. The reason to say that is we know chi is m divided by h. Here m is magnetization, h is magnetic intensity. So the applied field is in one direction and the material gets magnetized in the opposite direction, as we have seen in the point 3. So we can say that m and h are in opposite direction, thus chi has to be negative and is very small. So followed by that we have our fifth property. The value of relative permeability is less than 1. That is, mathematically mu r lies between 0 and 1. This can be given using the relationship between mu r and chi, that is mu r is equal to 1 plus chi. This also tells us that mu r is less than 1 because mu is very less than mu naught, which is because of the magnetic field lines which are trying to pass out of the material rather than passing through it. So let us now try to study the note on diamagnetic substances. Superconductors are the perfect diamagnetic materials. So the magnetic field lines in case of superconductors are completely expelled out of it when they are cooled to very low temperatures. Thus, they are exhibiting perfect diamagnetism. What do we mean by perfect diamagnetism? Perfect diamagnetism means chi should be equal to -1 and mu r should be equal to 0. The phenomena of perfect diamagnetism in superconductors is called Misner effect. Let us now try to study paramagnetic substances. These are the substances which exhibit paramagnetism. So let us define what are paramagnetic substances. These are the substances which are weakly magnetized when they are placed in external magnetic field. These materials move from weak to strong region in the presence of magnetic field. And paramagnetic materials are weakly attracted by magnets. Example for paramagnetic substances are aluminium, antimony, chromium, and etc. In the absence of external magnetic field, the dipoles of paramagnetic substance are randomly oriented. They are in random orientations, and if we sum up their dipole moment in case of paramagnetic substance, we end up to be having net moment to be 0. That means these are not having any magnetic field around them. So in the absence, they are randomly oriented and there is no influence of external magnetic field on them, and they do not possess any net magnetic moment. So what happens if we apply external magnetic field? When paramagnetic substances are applied with external magnetic field, then the dipole will get aligned in the direction of applied field. So in presence of magnetic field, we see that they try to just get aligned along the direction of magnetic field. Here the magnetic field is in upward direction and we see those dipoles getting aligned towards that direction. Because of this, they are getting magnetized in the direction of magnetic field. Let us now study about the properties of paramagnetic substances. Firstly, paramagnetic substance is weakly attracted by strong magnet. Second, when paramagnetic substance is placed in the magnetic field, the magnetic field lines prefer to pass through it rather than through the air surrounding it. As shown in the screen beside, we see that magnetic field lines are trying to enter more into the material rather than the surroundings. In the presence of external magnetic field, paramagnetic materials get weakly magnetized in the direction of applied field. Fourth property is the value of chi is positive and is very small. That is, it lies between 0 and epsilon. Here epsilon is a very tiny value. So the value of chi is positive. Reason is capital M is along the direction of magnetic field. That's why we are having M and H direction to be same. That's why chi comes out to be positive. Let us try to take the fifth point. So fifth point is the value of mu r is slightly greater than 1. That is, mathematically 1 is less than mu r is less than 1 plus epsilon. So we are writing this using the hint mu r is equal to 1 plus chi. So here we can say mu r is equal to mu divided by mu naught. Since mu r is greater than 1, we get mu is greater than mu naught. That means the magnetic field lines will prefer to pass through the material rather than passing out of it. Sixth point, paramagnetism is quite sensitive to temperature. Lower the temperature, stronger will be paramagnetism and vice versa. So paramagnetism depends upon the temperature. Thank you students, and see you in the next video lecture.